arc length. In this video, we're going to see two examples of how to calculate arc length. So for our first example, let's find the length of the curve x equals y to the 3/2 divided by 3 minus y to the 1/2 from y equals 1 to y equals 9. We're not even going to bother graphing this. What we're going to do is look at this. It's asking us to find the length of a curve, and it gives us x equals some function of y, and then they tell us that y ranges from 1 to 9. So this means we're going to use the form where we're taking integration with respect to y. So to start, we have our function x equals some function of y. We find its derivative. And once you have the derivative, you're all set to go forward with your formula. The formula is that arc length is equal to the definite integral from c to d of the square root of 1 plus the derivative of your curve squared. So we plug in what we know. C and d are our 1 and 9, and we found our derivative, and now we're going to square it. Now when we square it, look at it this way. You could think of your first term here as being called a, and your second term here as being called b. So this is of the form a minus b all squared. Well, we know that a minus b squared is equal to a squared minus 2ab plus b squared. So when we expand this out, we get that this integral becomes the integral from 1 to 9 of the square root of 1 plus, here's your a squared, minus 2 times here's a times b plus what we called b squared. And now if look at this middle term here, we can simplify that. The 1/2 and the 2 cancel each other out here. The y to the 1/2 and the y to the negative 1/2 cancel each other out, and we're left with just minus 1/2 for that term. Alright, so if we continue on with that, there's the integral again. Now I'm going to simplify some more by combining this 1 here with this negative 1/2 to get this integral. So now it's got a plus 1/2 here. Well, here's what we called a, here's what we called b. Look at what we can do. We can rewrite this right here underneath as here's that a squared plus 2 times a times b plus that b squared. Alright, and that's great. I haven't changed anything because when you multiply these three terms together right here, you come up with a positive 1/2. So I haven't changed anything. And now we know how to factor this. We know that a plus b squared is equal to a squared plus 2ab plus b squared. So what's under the radical here just becomes a plus b squared. And that's really cool. Because now what I can do is say, okay, I'm taking the square root of something squared. They cancel each other out. And now I'm left with the integral from 1 to 9 of 1/2 y to the 1/2 plus 1/2 y to the negative 1/2. And that's something we can evaluate. And when you do, you'll find that that's equal to 32/3. So you might want to take a moment here and pause it and make sure you can calculate that definite integral. Alright, let's do example 2. And it's going to use the same idea that we used in example 1 of taking what's under the radical and rewriting it as a perfect square. So here what we're doing is we're going to find the length of the curve y equals x cubed over 3 plus x squared plus x plus 1 over 4x plus 4 on the interval 0 to 2. Okay, so this time we have y as a function of x, and we've put limits on our values for x. So we're going to use the formula where we integrate with respect to x. So we start off with our function. We need to find its derivative. So I go ahead and find its derivative. And now we're going to do a little bit of algebra, because maybe you can see something here. These first three terms are x squared plus 2x plus 1, and that can be factored. And then here what we're going to do is a little bit of algebra. I'm going to take that here. I'm going to rewrite the denominator. I'm going to factor out a 4. And then I'm going to distribute my square. And then when I do that, I can cancel a 4 from the numerator and the denominator. So my derivative I can rewrite as x plus 1 squared minus 1 over 4 times x plus 1 squared. Alright, so now we take this and we plug it into our formula for arc length. The formula is the integral from a to b of the square root of 1 plus the derivative of our function squared. So that's going to be equal to the integral from 0 to 2 of the square root of 1 plus, here's our derivative, squared. Alright, so just like last time, think of what I have here in red as your a term and what I have here in green as your b term. When we expand that out, that becomes 1 plus, there's our a term squared, minus 2 times a times our b term, plus b squared. Okay? Now I'm going to, when I multiply these terms here in the center out, they can't simplify down to negative 1/2. Should look a little bit familiar. And now what I'm going to do is I'm going to combine that 1 and the negative 1/2 to get a positive 1/2 in the center. Alright? So now if you look at this, we can take this term right here in the center and rewrite that as 2 times what we were calling our a term times what we were calling our b term. Check, make sure you believe that that term right here is equal to 1/2. Once you believe that, then you can see this is of the form a squared plus 2 times a times b plus b squared. So we can factor that as a plus b all squared. And now we can cancel the square root with the square and get that our arc length is equal to the integral from 0 to 2 of x plus 1 squared plus 1 over 4 times x plus 1 squared. Now, to find this integral, you see here we have an x plus 1, and here we have an x plus 1, and there's no other x's anywhere. So let's do a substitution. Let's let u be equal to x plus 1. That means du is equal to dx. And since we're doing substitution on a definite integral, we need to change our limits of integration. So when our upper limit is equal to 2, we'll get the new upper limit's 3. And when our lower limit is 0, we'll get our new lower limit is 1. So now plugging in for our substitution, we get that this integral becomes the integral from 1 to 3 of u squared plus 1 over 4u squared du. And that's something we know how to integrate. So make sure you pause the video now and see if you can get the final answer of 53/6.